All right, question 5. So we're just kind of writing our formulas here. So I think we need to have about 4 of them down. They're in our math notes boxes, but definitely are going to need to know how to use them and know what they are. So arithmetic sequence, write a sequence of arithmetic using a, n, and d. So arithmetic, we write a, n equals a1 plus d times n minus 1. N is our term number, and d is our common difference. So how we use that is something like, arithmetic 3, 7, 11, ... So the nth term of that is equal to the first term plus our common difference of 4 times n minus 1. And I always like to double check, like if this is my a1 and I put a 1 in, I get a 0, my a1 is 3. If I put a 2 in, I get 3 plus 4 is 7, checks out. So then I could find my 10th term. 3 plus 4 times 9, so I'm going to add 4 9 times, and that's going to get me 39, I believe, if I kept going plus, plus, plus. Okay, and then write a sequence of a geometric using a, n, and r. So that one is our a(n) equals a1 r to the n minus 1. And what does that mean? That means if I have a geometric like 1, 2, 4, 8, ... I know that my a1 is 1 and my r is 2. So then I double check. 1 times 2 to the 1 minus 1 gets me 1 times 1, checks out. So then I can find my 10th term there if I want. 1 times 2 to the 9th power. And I hope that makes sense. The 10th term is the 9th power because for the first term we don't multiply by 2. But then we do multiply by 2 to get each term after it. So to get the second term, I only multiply 1 time. So to get the 10th term, I only multiply 9 times. And then we want 3 more, actually, formulas for our sums. So we're going to start with our arithmetic sum. So that one, I like to say the words first plus last over 2 times how many. So the proper way to write that is a1 plus a(n) over 2 times n. But if you remember the words, I think it's actually a little easier. Then the other thing on this one that I would expect at the pre-calc level is sometimes we don't know what that term is, and we might actually have to use this in there. That's just a little hint of what I would assume might be coming next. Then we've got our sum of a geometric. And that one straight up from the math notes box is just a1 times 1 minus r to the n over 1 minus r. All right, then we did have one good word problem here. Now, based on what the work we did in class and the questions we had, I made sure that I clarified some wording in here. Mark has decided to collect money. He's decided he's going to save some money to buy a motorcycle. He has $100 to invest initially. The bank has an annual interest rate of 1.5%, which is actually probably realistic, compounded monthly. Anytime we read something like that, we should remember that we're going to do 1.5 divided by 12 for monthly, which is 0.125%, which is 0.00125 as that multiplier. That's important. How much money does he have in his account at the end of the first month? So that's just straight up the 100 times 1 point, or I guess you'd see it as 1 plus, but 1.00125, which is of course just $100 with an eighth of a penny behind it. Which is realistic. Like, you're not going to gain a lot of interest on $100 at 1.5% monthly. If he adds $100 every month and it continues compounding monthly, how long does it take for him to collect $6,000 for the bike? So that's the one where we want to do this. This represents how long. The very first month is going to get n compounds. Then every month after that is going to get one less than the month before it. And if we recognize this work, it's just a geometric series. So then we go up and we grab our geometric series formula and we plug it in. A1, 100 times 1 minus R, which is 0.00125 to the n over 1 minus R. That's going to give me my sum. Now I want to know, when is my sum going to be equal to $6,000? So I'll do that math with us. So we're going to fraction bust this over. So we're going to multiply by negative 0.00125. 6,000 times negative 0.00125 is so I've got 100 equals, or 100 times 1 minus 1.00125 to the n equals negative 7.5. Divide by the 100 right here. So I have 1 minus 1.00125 to the n equals negative 0.075. Subtract the 1. Negative 1.00125 to the n equals negative 1.075. Multiply by the negative, so make them all positive, and then take our log. Log base 1.00125 of 1.075 equals like 57.9 something. 58 what? Months would be important. Years would be a bummer.
Alex, will ma'am please come to the main office?